Enzyme activity is influenced by the physical and chemical environment. So any conditions that affect the enzyme's shape and binding ability affect its catalytic action. Three such conditions are temperature, pH, and presence of heavy metal ions. First, we'll look at temperature. Going back to kinetics, we know that the rate of a reaction is increased by a rise in temperature, due to the increase in the average kinetic energy of the particles, so there are more collisions. But this is only true up to a certain point when talking about enzymes. After the optimum temperature of about 40 degrees Celsius, the effect of the increase in kinetic energy changes the conformation of the protein by disrupting the bonds and forces holding it together, which consequently renders the enzyme unable to bind the substrate to the active site, and its catalytic activity is diminished. Next, we'll look at pH level. Changes in pH represent changes in the hydrogen ion concentration, and this affects the equilibrium positions of ionization reactions. When these reactions involve the R groups of amino acids in the enzyme structure, the change in ionic charge alters the attractive forces stabilizing the molecule, and thus its shape and its ability to bind substrate. The specific effect of pH depends on the pKa and pKb values of the R groups of the amino acids, especially those at the active site, and so is different for each enzyme. In most cases, there is a clear optimum value for pH. As you can see in the graph, the optimum pH for pepsin is about 2.5, and the optimum pH for trypsin is about 6.5. So much like high temperatures denature enzymes, extreme pHs also do that. Last, we'll look at the presence of heavy metal ions. Heavy metals such as lead, copper, mercury, and silver are considered poisonous, primarily due to their effects on enzymes. When present, they react with sulfhydryl groups, or this SH group here, forming a covalent bond with the sulfur atom and displacing the hydrogen ion. This disrupts the folding of the protein, which may change the shape of the active site and its ability to bind substrate. This is a form of non-competitive inhibition.